Here's a little good learning moment when somebody says they're just going to replace filters and substitute one filter for another filter on a standard system. Well, if you've noticed, these are Merv 16 filters, and we all hear about the bad taboo of putting higher Merv filters inside systems that were standard and not engineered for it. And that would be the case if this was a standard system. But I actually measured, tested, engineered, ran the math to have Merv 16 filters, and as you see, there's 3 of them here going across. Well, there's also 3 more going all the way back on top of that, going further back down there. So you got filter mass that's Merv 16 5-inch deep pleated going across this whole area. That is your filter area going into this tiny duct. So the face velocity going over here is less than 200 CFM per square foot of face area, surface area across this whole ducting system. And measuring it, I measured it to make sure that I don't have excessive filter restriction. So for this situation and this scenario, Merv 16 is an excellent choice filter because I actually constructed the whole system. Now, the filter racks I wanted to make in here were going to cost a lot of money, and they wanted to keep their costs down. And so basically you just have this little piece of tin here. That was what are, to go over the filters. What I wanted to have was something that had hinges, doors, tightening knobs, screws around it with gasket material to actually make it airtight. But that was going to make the costs run so high up that they didn't want to do that times 6 on, because there's six of these out here. And so this is the cheap handyman that even your janitor can change filters and repeat. Got a little tape here. We got a little seam. See this little seam right here? Well, it's not doing on this one so much, but I actually can measure. Where the hell's my tape? I can measurement. This is a little bit negative on this side of the filter, very little. But on the other side, the room is positive because they're leaking right now, and so air is being sucked into the system past the filters and making the whole room positive pressure. So I'm sealing that up right now. Now you take something like this. I have a smoke, I'll show you later on. I'll make a video using the little smoke producing machine, kind of like those vape, you see the e-cigarettes, the vapor, the white vapor coming out. One of those going around leak testing, looking for leaks using a smoke machine. But in this case, if you can't afford and you don't have, you could use a cigarette, you could use a piece of incense with a piece of smoke, or here's a real simple one. Okay, so there we got a piece of paper. Whoa, it blew away. What happened there? That's positive pressure. You don't need a expensive piece of equipment to see that. That's visual. That's something you could do for no money. A piece of incense, a cigarette. Remember what was called a punk, a wick? When you would light firecrackers, you get a piece of jute rope. How many young guys know what jute is? But the old-fashioned sailor's rope made out of a weed, and you would light it and it would stay an ember. A little bit of smoke would come off that, and you used to light your firecrackers when you were a kid, your barrel bombs, cherry bombs, M80s. You could tell I was a kid who didn't care about the laws and rules and regulations. So you could use something like that and just go around, and you would see the smoke go up, and you'd get to see the smoke get sucked right in. You know you have a leak and it's sucking in. Then you would move your smoke down to something like this, and you would see that there's air shooting out of here, and you have a leak, air exiting, because the room down here is under positive pressure. This is the air intake, so this is your return. This is under a negative vacuum. It goes into the air handler. Then on the other side of the air handler is positive pressure, and then it shoots back down into the room and the room is under positive because it's picking up a supply of extra air it doesn't need and shouldn't have past the filters. And that's what I'm doing here, is I'm sealing it off with this. Another thing you could use, if this can aid you, if you have a very large filter bank and you need to have a large area, this comes in different sizes. It's basically saran wrap. This is, you get at U-Haul. Very cheap, inexpensive, and you get like 1,000 feet of it or something like that, or a few dollars. You could pull that tight over your ends. But right now, I'm taping it up with painter's tape. I'm sealing up this edge. I'm gonna seal this edge, seal these edges, seal the corners, and just pull this quickly over it and tie it down on the ends. And then I'll reapply and I'll put this back in place over it like that. You know how they say change your filters every month, change your filters every 3 months. This is kind of a clean room application here, and I'm gonna put a old manometer up here, the old analog style, and I'm actually gonna read the filter drop, the pressure drop across the filters between new and bad. I'll write on there with a little permanent marker on the needle, so the customer could come up here periodically and check them. And when you get to this many tenths of filter pressure drop, it's time to change the filters. So instead of changing thousands of dollars in filters every couple months, because this air handler runs 24/7 and it will never stop for the rest of its life. It's basically on and never stop unless it breaks or PG&E power goes out. That's it. So there'll be air moving across these filters every day for the rest of their life. But I designed it in a way with there's enough mass, even being Merv 16, they probably shouldn't have to change these filters but once a year or even more. And I told them it depends on how clean you are in that room. And this is supposed to be a very clean room. This is what I've done for years. This is what my dad taught me, but it's all in the math. Unlike these professionals who have, who installed this system over here. So you can see there's a Bryant system over there. Right there, those pieces of dog shit. Nothing wrong with the company, there's something wrong with the people who installed them. They upgraded the filters in there in the factory little slot that fits down inside the system to Merv 13, and they're highly restrictive for the application they're being used in. Then the ducting work that they have in those systems in that room over there does not have enough outlets and diameter for the filter flow for those 5-ton units. It's highly restricted. So right off the bat, those 5-ton systems are putting somewhere out about 4.2 tons of cooling, 3.8, 4.2, because some of them have different problems in their airflow, but yet they're 5-ton systems. They paid for 5-ton systems. They have up on the roof, they have 2 Toshiba, and they spent, I don't know, 50 grand, 80 grand to have the system put in, and it works like dog shit. Because they told me, oh, but it was engineered by engineers for airflow. Bullshit. There's no drill holes for test ports. They didn't test shit. They put their hand up there. I got cold on my hand, sir. Give me 50 grand. Thank you very much. And I write on a piece of paper, the system is engineered. F you. That's what I say about these big companies who have a lot of hard-pressed salesmen to make money and do nothing for it. They want the easy way out. So finish up all my testing, go back to testing again, and prove and document my improvements of airflow and infiltration and the pressurization or depressurization of the room before I leave. I don't collect my money until I can back up my data by testing first, documenting it, put it down in Measure Quick, Field Piece, Testo software, record it, take a snapshot, and include it on your customer's invoice and their digital paperless receipts and stuff like that. So they have a copy of what you've done, you have a copy, and take photograph of every step and procedure you have performed. That's it for now. Just this short little rant about doing your work or not doing your work. Yes, the customer doesn't even know that this is a problem. I could walk away and collect my money today and say I'm finished, and they'll never know that their filter life will be short because they're sucking in dirty outside air, and their air handlers will get dirty, and I'll be called out to do services on them every couple months or every year or so because of dirty air handlers, because of bypassing the filters, and I'll make a lot more money that way. But that's not what this is about. It's about giving the customer that extra measure of service that doesn't cause me to come back and make more money, that makes my equipment last longer, that my equipment manufacturer could get a good reputation and a good name for being reliable by not being installed improperly and causing problems. Even the mold and spores, and you live around a watershed area where there's little streams around here and open ponds of water, and the spores from algae go into air, get sucked up past the filter right here, go directly into the pan and on the wet coil, and you get that booger snot, that algae, black growth, brown growth, green growth inside your condensate drain. It plugs up because it bypassed the filter. So you get a lot of return work coming back and keep cleaning out clogged condensate drains. But if you have to pull through a Merv 16 filter and it's sealed everywhere, with my experience on systems like this, 5 years, 8 years later, I come back and the inside of the coil and the pan are perfectly clean, and I don't have to come back and maintenance them. Customer doesn't have to pay me. That's extra money I don't make, but my extra money comes from having a system that goes in and doesn't break down, unless an idiot works on it after me and does something to make it break, which often happens when someone goes, oh, new manager comes in and say, I'll call this guy because he's done my other equipment, and he touches the shit and breaks it. That happens a lot too. All right guys, see you later.